Friday we talked about a robot and how it decreases value every year, and it was accounting, and it went down exactly $7,250 every year. Now, in the real world, things will show slope and rate of change, but it won't be like so consistent. Like in biology, for instance, DNA has some diversity in it. So we'll see a relationship here in number 44. It's talking about the length of a humerus bone and a human height. And as someone gets taller, their humerus bone also gets longer. But the rate of change isn't quite as precise and exact as you would see like in accounting. So when one person's humerus bone goes 1 centimeter up, maybe their height only goes half a centimeter, whereas another person might be 1 centimeter here and like 1.2 here. You know, it kind of varies. So it comes out as a scatter plot instead of a perfect straight line. So today we're going to draw the scatter plot, and then we're going to put a line through the data called a line of fit. And so we're going to do it by hand. This is it, Tuesday. We're going to do a line of fit by hand. And then we're going to have technology calculate a perfect line of fit for us. And that's why you need either a calculator or a Chromebook. Okay? So our goal is to learn how to use technology to find lines and scatter plots. So here's our little skeleton, arm bone and height. And here's our data we're going to be working with. We need to make a scatter plot, so let's get to it. The x-axis is the arm bone, and the y-axis is the height. I'm going to draw it here. Yours is probably going to be a little better than mine because you're on graph paper. So I got my humerus bone in centimeters. Now, it's from the littlest value is 22 up to 33. So I'm going to put a break in my x-axis, a little boop, boop, like that. And then I'm going to kick off at 20. And then on the y-axis, I'm going to break 2 because I don't want to go from 0 to 130. So I'm going to boop, boop, break it, and I'm going to start at 130. And then I'm actually going to go by 2s so I can fit all that in. So boop, boop. I should label it. What's this one? Yeah, this one 130 to 166. So if I start at 130 and I go by 2s, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. All right. And then a scatter plot just dots all over the place. So it's a bit of an estimate where your dots land. It's not super precise. When you move up in math, like once you get to AP statistics, things get more and more precise. When you're writing the line of fit, you think about the correlation. Is it a tight correlation or a loose correlation? And how much each point deviates from the line. All right, our first ordered pair, 33, 166. Way up here. First data point. Second one, 25, 142. That's not that good. Over. I've done this today 3 times. And my one time I did really good, and then last class my numbers weren't as good. So I'm going to try to do better. 22, 130. That could be it right there. 30, 154. 28,152. One place this comes into play is like people who do ultrasounds for babies that aren't born yet. They'll measure like the skull or an arm bone, and then they'll tell the mother how long the baby is. Not because they were able to measure the whole height of the baby, but they have data that says, oh, if the skull is this many centimeters, this is the approximate height of the baby. Same idea. Or if you're more into like true crime scenes, if you've ever heard about like here in Florida, like a body found in the swamp or the Everglades and they don't have the whole skeleton, but they can get parts and use data and say, oh, we think this was a 6-foot male, based on that one bone. They can predict the height. Same idea. Where am I at? 28,132. I did that one. 32,159. I did that one. 26,140. 27,145. And here's my scatter plot. Now, if we would have done this with the robot depreciation, the lines would have fallen in a perfect straight pattern. But so many things in real life, the rate of change isn't perfectly straight like that. So we need to use a line of fit. When you do your line of fit, use a straight edge. You can use your ID or your folder or a ruler, and everyone's line is going to be a little bit different. That's okay. But what you want is your line to go through the points. Don't connect the dots. This isn't a connect the dot exercise. But I sometimes have to try it 2-3 times before I feel good that it's right through the center of the data. I don't want a line here. That's not it. It needs to be right in there. And I don't want my line down here where all of the data are above it, or up here where all the data are below it. I want to try to get the same number of points above as below. And so if you want to do it lightly with a pencil in case you have to erase, I recommend that. I keep trying to get about 3 points below, 3 or 4 points above. It's not really easy. I'm going to go with this for now. See, I put my best effort in and it didn't come out very good. 1, 2, 3, 4 below. Actually, it's not that bad. I got this one's above, this one's above, this one's kind of above, and this one's above. Let me try it one more time. That actually was pretty good. I'm just going to try to go a little bit more slanty. So let's see. I'm going to keep this one 2 points below, 2 points above, and then I've kind of hit 3. But don't feel like you have to hit points. Sometimes you draw a line of fit and you don't hit any points, and that's okay. So now I have to make the equation for the line. And we did something similar Friday. When I do it by hand, I'm going to find 2 points on the line, and I'm going to do slope formula. y2 minus y1, x2 minus x1. So where's my points on the line? If there aren't any, you can draw new ones. For instance, if I go up from 30, I land right here. I go over, and it looks like I'm making a brand new point at 30,155. You're allowed to do that. Make a point on your line because you want a slope of your line that you drew. So when I look around the room, everybody has different lines, so everybody can use different points. If you want to use my points, you can, so you're doing the same work as me. But if there's a couple of brave people in the room, if you want to pick different points so we could compare, go for it. Pick some points on your line. It doesn't have to be just like mine. My other point I'm going to do is 25. I'm going to use 25, 140, and I'm going to call that x2, y2. And it really doesn't matter which one you call 1 or 2. And so now I'll find the slope of the line I drew. $140 minus 155, 25 minus 30. And it worked out really nice, but if you guys, I mean, I've had all types of decimals today. I had 3.2, 3.4, 2.6. So don't worry if you get a decimal. This one just happens to be a plain even 3. Okay, so I need a whole equation. I'm looking for y equals mx plus b. So now I need to know b. To find b, I'm going to do point slope form. And you did one of these Friday. It was number 4 for ball work. Y minus y1 equals m times x minus x1. To use this formula, I'm going to use the first point I wrote down and the m value I just found. Use distributive property. Get your y alone. And this is a pretty good equation. I got y equals 3x plus 65. Anybody pick different points that I did not do? Anybody get a different slope besides 3? That's okay. I kind of went through it quick. Who's got a question so far? I'll pause and let you catch up. If you don't have the TI-36 calculator, this is where you're going. You're going to desmos.com, the graphing calculator, and we're going to make a scatter plot on that and have the software draw the line of fit for us so we can see like a good perfect one. More and more, we need to encourage you to use technology in math class. All the math careers are very good with technology. So let's put a data set into a computer. I'm going to do the work for us. See, it says use technology to find the line of best fit. So look at the word best here. Best fit is done by technology. Regular fit is done by hand. Okay, with your calculator, you're going to find the data button. It's here, up at the top. Does anybody want me to wait? I don't mind waiting. Okay, here's your data button. When you click your data button, you're going to see 2 lists, actually 3 lists. You ignore the third one. That's for like a third coordinate, like X, Y, Z in Minecraft and Z. We're not doing Z. So we have L1 and L2. You put all of your X values in L1. So when I look at the table, the first one is 33. So I type in 33 and I hit enter and it goes to the second. And then I do 25, enter, 22, enter, and you fill in a whole column of X's. And then you arrow over this circle. This cursor is really helpful. You arrow over to fill in the Y's under L2. Okay. No, use the problem in your book. So we're entering the exact information from the book. I love the conversations going on. Please talk to each other. Ask each other questions. Why can't I get this to work though? All right, in Desmos.com, find the plus sign. Find the plus sign in Desmos.com. Put in a table, pick table. And you're going to fill all of the values in the X and the Y column. I lost all my numbers. Do it again. $28. Are you good? Hit the plus sign and then go to table. 32, enter. 26, enter. 27. So I'm filling in the table about the bones that we already graphed by hand. And now we're going to see it appear. And there's the scatter plot. Who needs help with the calculator? Please talk to each other. Help each other out. Say, hey, I can't get up all this, and some people really get stuff at the top. Maybe your calculator's not working. Okay. After L1 and L2 is full on the graphing calculator, you go second data. Second data. And then you use the cursor, you scroll down, down, down till you see linreg. That stands for linear regression. Linear because the data does follow a linear pattern. Regression is all of the points coming together to make one line. Hit enter on linreg. It's number 4. And then you scroll down. The bottom right has all caps calc. Go to calc and hit enter. And it calculates it for you. For some reason mine is wrong. Yeah. It stands for linear regression. It's number 4 in the second data. Now, your calculator, instead of mx plus b, uses an a. So the a value they list, 3.05, is the most precise slope for the line of best fit. And they tell you b value 63.53. So that gives us this equation, which is pretty close to the equation we did by hand. In Desmos.com, you're going to go to the next empty line. So this one, this number 2 here. And you type in this exactly like it looks. Y1 squiggle, find the squiggle, I use the keyboard for that. M x1 plus b. And this means Why is this like using the mouse curves to it? All right, so here is the M value calculated by Desmos, same M value. Here's the B value calculated by Desmos. So pretty great cheat code. It's doing everything. It's tracking the line, it's finding the slope, it's finding the B value. It's the software at work. Yes.
How do you know what's around to?
Let's do 2 decimals. Let's do the 1,000. All year, if I don't specify, you can do the 1,000. Okay. So our equation by hand is pretty close to the software equation. Haley, let's hear your question. You got something?
No, I was trying to 1,000. It's a whole question.
No, it goes 10, 100,000. So it's 3 to the right. Other great questions. Okay, there's not a lot of questions. Let it rip. Okay, let's go back to the question. Okay, use the question. So our equation is y is approximately 3.05x plus 63.53. Now it's going to say estimate the height of a female whose humerus is 40 centimeters long. So you have to write the equation and then you will have to use the equation. So what this means, the humeruses are the x values. So we're going to go x equals 40. We're going to plug in and use the equation to find the height. So we're plugging in for x. And it's like 185 or something. 185.53. And then this is a real world application problem, so we need to answer in a complete sentence. The height of a human female? Does it say human? It just says several females. And then there's our answer. So write the equation and then plug in and use the equation. And that's your mission today. It's important that you practice these buttons on your own, that you have some time to work together. So you have 4 problems. All of them are meant to be done with technology, with Desmos.com or with the calculator. And it's easy to forget this stuff if you don't practice it enough. So please get right into it. You're inputting data in the calculator or the table. You're writing equations and answering questions about the equation. And I want you to come to me. I'll be sitting here, but come to me with your calculator or your Chromebook and let me know what's not working. If your calculator's not working, bring it. Or if your Chromebook's not working, bring it. You have the rest of the class to work on these together. Tomorrow I'll be checking Friday's assignment and today's assignment. It's all in the same section.